All right, and so the rest of this unit, you're going to be kind of finding that our focus is going to be looking at data trends and figuring out like the relationship between skewed data and data that we say is distributed normally, which is essentially like when your data is symmetric. So thinking back to that histogram when we've got that bell curve. So what we're going to talk about today is something called standard deviation. And standard deviation is a way to kind of like compare measures of center and to figure out like how your data is spread, kind of. Okay, so the definition for standard deviation is a measure of how much a typical value in the data set differs from the mean. And that numerical value will give you an idea of how spread out your data is. The symbol sigma, that's what this is right here, is like the symbol that represents standard deviation. So the way you kind of draw it is like a little O with a little hat on it. And I'm not actually going to write like the formula here yet. We're going to kind of work through one right now, because if I were to write this formula, it would be very overwhelming. It's overwhelming for me to even look at. Okay. And so what you're kind of doing when you're finding standard deviation is you're kind of like finding the average of the average. And so what we have to do, and it kind of goes with this definition, is the first thing we have to do is figure out what your values are, what the mean is, and then we'll go from there. Okay. So the first thing you're going to do, and I created this little table to help organize our work. A lot of times people will almost just kind of copy this down when they're doing their work. You can kind of skip a couple of the steps once we go through a couple of the examples. And you'll kind of see what I mean from that. And so the first thing we're going to do in this column is just copy down the values in your data set. They do not need to be in numerical order because we're not doing anything with medians here. So I'm just going to go ahead and copy all these down. So 20, 19, 27, 30, 20. Sorry, probably hear my kids upstairs in the background. All right, and so the next thing we're going to do is find the mean, right? That's what that X bar is. So there are 12 total values. So when I do that, $300 divided by 12 is 25. So the average age on this game show is 25, and I'm not going to write this every time, so it's the same mean for every value. Okay, so now we're going to go and kind of use this definition for standard deviation. How much does a typical value, which is like your average value, essentially differ from the actual mean of your data set? So we are going to find the difference between your data value and the mean. So if this person is 20, the average age is 25, that means that is going to be -5. So this person is 5 years younger, which is why we kind of make it negative. And then 19 minus 25, so that means that this person is 6 years younger than the mean. And we're going to keep doing that all the way down. So 25 minus 25 is 0. This person is 2 years older. This person is 5 years older. This person is 4 years younger. That person is 4 years older. This person is 3 years younger, 2 years older, 4 years older, 5 years younger, 6 years older. Okay, so you can kind of see whether it's positive or negative based on, are you below the mean or are you above the mean? Okay. Well, since we're kind of talking about like a distance, how far does a typical value differ from the mean? We can't have these negative values, which is why we do this column right here. So we need to take this value and we need to square it to make it positive. So that would be 25, 36, 0, 4, 25, 16, 16, 9, 4, 16, 25, and 36. And so now what we're gonna do is find the average of this column, right? We're trying to figure out how much a typical, so an average value, differs from the mean. So these are how they're all related in terms of the difference from the mean. So I'm gonna take 25 plus 36, 0, 4, 25, 16, 16, 9, 4. Okay, so I'm going to write this off to the side now. So my standard deviation is going to be 212 divided by 12. Now, since we squared these values to make them positive, the last thing that you're going to have to do is undo that squaring. So taking the square root of that average. So my actual standard deviation is going to be the square root of 212 divided by 12, so about 4.2. Okay, so I'm going to kind of walk through that. So what we did is we just listed out all our values and we found the mean. And then we found the difference between our data value and the mean. But we had to square all of those values to make them positive. And so when we find actual standard deviation, we're finding the mean of this column right here. And then in order to undo the squaring that we did to make these values positive, I took the square root of that average, and that is what standard deviation is. And so what this value tells us is that the typical data value differs from the mean by about 4.2 years. And this is pretty much how you'll always express your answer when it asks you to interpret your result. You'll start with this little phrase, the typical data value differs from the mean by, and then you'll write your standard deviation and whatever you're finding the deviation for. So since these represent ages, that would be 4.2 years old. So what that means is that the typical value, the typical person is around either 4.2 years older or 4.2 years younger than the mean of 25. Okay, so we're going to run through that one more time and then we'll talk about how you compare standard deviations and what that means about the spread of your data. Okay, all right. So my first step again, this is the same meaning, just a different show. So we're looking at a game show. So we're going to start by writing down all of our values. All right, and then just to save a little bit of time too, you can practice this on your own. I already calculated this mean out, and the mean on this show is 26. So the average age is 26 years old. All right, so now what I'm gonna do is I'm gonna kind of leave this column blank and just show you how you can like skip to this one when you're actually doing the work on your own. I'll work it out for these first few, but then I'll skip it for the next ones. All right, so now I'm gonna find the difference between your data value and your mean. So this person is 1 year younger, and then when I square it, I get 1. This person is 6 years younger. When I square it, I get 36. This person is 4 years younger. When I square that, I get 16. And so now I'm just gonna kind of do this in my head. So that's a difference of 1. 1 squared is 1. This is gonna be a bigger one. 48 minus 26, that person's 22 years older. 22 squared is 484. That person is 6 years older. Square that, you get 36. 7 years younger, you get 49. 1 year older, square it, you get 1. 1 year younger, square it, you get 1. 4 years younger, square it, you get 16. 5 years younger, square it, you get 25. 2 years younger, square it, you get 4. Okay, so first of all, before we even find the standard deviation, we can predict that the standard deviation is probably going to be a higher value than we got in the first example, because this 484 and even the 49, that value is a lot different than the other ones. So thinking back to even what we talked about in 9.1 in terms of outliers, this 48-year-old would probably be an outlier if we were to actually calculate it, just because we can see that value is going to be so much bigger. And so if we think about what that would look like when we plotted these values on like a histogram or a box and whisker plot, this person is going to make the mean higher. So it would probably be skewed right if I were to actually like display this data. But let's kind of show that in terms of calculating standard deviation. All right, so now I'm going to add all of these values together. And again, just to kind of save a little bit of time so you're not watching me type it in, I already did that. And you get 670 when you add that column together. There's 12 values. And then to find the standard deviation, I need to undo the squaring. So I'm going to take the square root. So the square root of 670 divided by 12 is about 7.5. And so what that means is that the typical, and if we even wanted to be a little bit more specific, inside of the typical data value, you can just use that little phrase, or the typical person or age of a person on this show differs from the mean by about 7.5 years. So when you're analyzing standard deviation, the bigger the value, the more spread out your data is. So when you're comparing show A and show B, since show A's standard deviation was smaller than show B's, that means that the ages on show B are more spread out. Okay, so if I were to just give you 2 standard deviations and ask you to compare them, that's kind of what you're looking for. Which one is bigger? What does that tell you about your data? So you want, if your data is normally distributed, that means the standard deviation is going to be a little bit of a smaller value. And so this is just to kind of guide us into what we'll be doing tomorrow too, when we'll be focusing on data that's like normally distributed. that means that your data set is not skewed. So that means that if I were to graph this on like a histogram or a box and whisker plot, your data would be symmetric. So that means your data is clustered around your mean. Everything is going to be kind of pushed towards the center. Whereas if you have, so that's again what a low standard deviation tells you. If you have a high standard deviation, that means that your data is more spread out. So that means your data is either going to be skewed left or skewed right. Again, in this case, it would be skewed right because that age is significantly higher than the other ones, making your mean not as accurate in terms of describing the measure of center. Okay? All right, so your homework is posted on Canvas. I need to make sure I see some sort of work for standard deviation, not just an answer. And if you have any questions, just let me know.